My name is Reddy Matthew, and today I and my team member Ricardo Mello would like to present our project, which is based on the Millennium Goal of achieving universal primary education. The introduction. In 2010, the enrollment rate in primary education reached 90%, up from 82% in 1999, which means there was an increase in kids attending primary school. However, in 2012, 58 million children of primary school age were out of school, which tells us there has been a reduction in primary school enrollment. The purpose of the project is to focus on achieving the goal of universal primary education by using the data provided by World Bank to create models that would determine which variables have greater weightage for a high enrollment rate. The next slide is the data preparation, which involves data access, data consolidation, data cleaning, data transformation, and data reduction. The first step is data access. The education data was obtained from the World Bank's online database. The 3 Excel sheets were fetched from the World Bank site. The files were educational statistics, which is now called as EdStats, GDP, and population. The dependent variables used were the net enrollment rate for primary education. Some of the independent variables used were the staff compensation, government expenditure for primary student, GDP per capita, and percentage of trained teachers. The data consolidation step. The issue was merging all 3 Excel sheets to a single data set. The procedure used in SQL, we created a view to join the 3 sheets based on the common keys. The common keys used were the country code and year. Justification was most of the variables used were from the EdStats file. But after discussions, GDP and population were also important variables, and hence had to merge all the 3 files to a single data set. Next step is the data cleaning. The issue was there were a huge number of variables in the EdStats file that were unrelated to primary education. So the procedure, we got the data into Excel file. In Power Query, had to filter out the variables not related to primary education. Some of the grouped variables like Africa dataset, Paroli, and DHS had more than 50 variables that were unrelated or unusable for our analysis, and so were removed. Justification is the sparse data for some large group variables would not help in our analysis, so had to be removed. Next slide is the data transformation. The issue we had was most of the data type we received from Excel were in text format, and numerical operations could not be performed on text data. Another issue was that the variables were in rows and not in column attributes. So the procedure, we used Visual Studio SSIS package to fetch all the 3 Excel files and transform the data type to varchar and float. The year columns had to be unpivoted to be defined as rows, and the variables had to be pivoted to be defined as columns. The justification to perform numerical analysis, the numeric data with data type text had to be converted to float. This pivot and unpivot was done so that the variables, which are the attributes, have to be in columns to use for any analysis programs such as R or IBM SPSS. This is the SQL code that was used to pivot and unpivot. As you can see, the year was unpivoted and the variables were pivoted. Next slide is the data reduction. The issue was that the adjusted enrollment rate, which is the target variable, had null values which had to be removed for modeling purpose. The procedure was for the dependent variable, we deleted the rows with null values, and the justification was the target variables cannot be null, as modeling had to be done based on the variable. I'll pass the rest of the presentation to my other team member, Ricardo Mello. Thank you.
Hello, my name is Ricardo. I am Reddy's group member. I'm going to be talking about building the model, assessing the model, and lessons learned. Now we're going to talk about model building. A few things to take into consideration in regards to data. First, the target variable is a continuous variable. school enrollment rate can be anywhere from 0 to 100 for each country. For that reason, logistics regression was ruled out. The data is linear, so we're going to utilize three different models: linear regression, regression, and neural networks. And the independent variables are continuous, and for that reason we broke them up into categories in the style of low, medium, high. I'll talk about that in some more detail in a little bit. Exploration issues. No values in the data set were changed to blank, so that we can change the storage type to continuous during the model building. And also the no values in the dependent variable were causing errors in R, and the values were changed to NA to perform descriptive statistics. Alright, this is the exploratory analysis. What you see here is the simple descriptive statistics. On top we have our dependent variable, which is the adjusted enrollment primary rate. We see such things as the mean, the media, maximum value, the minimum value, variance and standard deviation, as well as a few other items. Below that we see for the independent variables, and you see the same data for those variables. Here we see a little bit more detailed descriptive statistics show for one of the variables. Expenditures on primary education as a percentage of total government expenditure. Alright, on the top left we have a bell curve representing the data, and then we also have some more statistics in the bottom left, as well as a few more visualizations of the data. We also enter the data into R to verify the descriptive statistics, and as you can see here, each variable has a minimum value, a max value, a mean, median, a little bit more information here. As part of the exploratory analysis, like we said earlier, we divided the independent variables into different levels. Over here we have GDP per population, broken into six variables, starting from poor and going to super high. And as you can see, as GDP per population grows, so does the enrollment in primary school. Then we then put the data into Power Pivot to do an analysis on the adjusted enrollment rate for primary education. I'm going to show here. This is what we got into Power Pivot, and as you can see, some of the information is inversely related to enrollment rates. Things such as the repeaters with primary grades and cumulative dropout rates, we expect those items to be inversely related. One item that has surprised us was the expenditure on primary education as a percentage of government expenditure on education that is inversely related as well to enrollment rate, and that was a bit surprising. For building the models, we utilized IBM SPSS Modeler. The first model was linear regression. That model summary gave us 89.6% accuracy, and the most important factor was the repeaters of primary, all grades. The second model was neural networks, and that model summary gave us 98.3% accuracy, and the most important predictor was expenditure on primary education as percentage of government expenditure on education. And the third model is regression. The most important predictor was also the expenditure on primary education as percentage of government expenditure on education. And that regression model gave us this equation, and as you can see, each variable has its own coefficient. In this case right here that I'm highlighting, it's a negative coefficient, show that the dropout rate is negatively related to the enrollment rate. Okay, now we will look at and analyze the results for each model. The first model we have is regression. It shows that we had one very strong independent variable, and that was the expenditure on primary education as a percentage of expenditure on education. We also had two decently strong independent variables, the GDP per capita and the repeaters of primary school for our grades. All other variables were negligible. Our second model is neural network, and as you can see from the chart below, some of the variables are stronger than others, but all of them play a part in predicting the dependent variable. Our third model is linear regression. You have one dominant independent variable, which is the repeaters of primary school for all grades, and then two decently strong independent variables, staff compensation as a percentage of total expenditure on primary institutions, and GDP per capita. All other variables were very weak or negligible. Now, comparing and assessing the models. Our model of choice that we think best describes the current situation is a neural network. We looked at this in two manners. One is subjectively, which is more opinion-based. The regression and linear regression determined that certain independent variables to have a negligible effect on a dependent variable. For example, labor force of primary education and out-of-school children of primary school age, and percentage of teachers in primary school who are trained. So basically the regression, linear regression, told us that it didn't matter whether or not the teachers are trained. That didn't have effect on the enrollment rates, as well as the labor force for primary education, and that is something that, you know, subjectively speaking, we're not totally comfortable with those results. Now, objectively speaking, both regression and linear regression determined that GDP per capita had a very strong effect on the dependent variable. And then both regression and linear regression also determined that expenditure on primary education as percentage of total government expenditure on education was negligible. So what that means to us is that the factor that determines how much much money the government makes, you know, the GDP per capita, it exemplifies how much government makes, is very strong. However, the factors such as the one given here that determine that show us how much the government spends on education was negligible or very weak. The problem we see with this is these models were telling us that if the government makes, you know, great amounts of money, that it has a strong effect, but it doesn't matter whether or not the government actually spends this money on education. So if you have a country, for example, that makes, brings in strong income through taxes on the GDP, but spends none of that income on education, instead decides to buy fighter jets and tanks, then by those two models, regression and linear regression, it should have a high enrollment rate in primary education, and that is also something that we had some issues with. As a summary to the presentation, we utilized data that was made public by the World Bank. We created 3 models for understanding factors relating to primary school enrollment rates. Of those 3 models, the neural network was the best model, both subjectively and objectively. And some of the lessons learned from this is that, one, societal factors play a role. Things such as adult literacy rate and labor force with primary education. As we saw from the neural network, they play a role in determining primary education enrollment rates. Economic factors play a role, such as GDP per capita, which is this representation of how much money the government is bringing in through taxes on GDP. That plays a role, but also governmental factors play a role, which is the government spending on education as a percentage of total government spending. So not only is it important how much money the government is bringing in, but also how much money the government is spending on education.